Okay, good morning, everyone. So first of all, I would like to say thank you to the organizers of this meeting for giving me the opportunity to talk today. And you see, it's a great privilege for me to talk in front of this audience. And I think it's also a great opportunity for me to reconnect with a number of old friends and mentors. So my name is Simone Severini. I work at AWS. And my talk is 10 things to know about quantum computing on AWS 2021 edition. And you see, I wasn't feeling particularly creative when I was preparing the talk. So I shamelessly copied the title of the talk that Nadia Haraldsson gave at Q2B last year. So it's identical to mine. But then when preparing the talk, I said, 10 things, it's a little bit too many. Human minds can't really deal with 10 things. I probably should talk about 5 things. And so I stabilized the title of my talk to 5 things to know about quantum computing on AWS. And that's the final decision that I took. So number 1. Okay, so number 1, I would like to talk about what our customers ask us when it comes to quantum computing. Right, and how conversation with customer is driving what we are trying to build, what we are building today. And by talking about this topic, I hope I will give you some feeling about why AWS is working in quantum computing and why now. And so you see, from the time I joined AWS, which was roughly 3 years ago, I spent a lot of time talking to customers. And customers and partners, and people are doing an amazing job in quantum computing, right? I'm talking about academia, startups, large enterprises, government agencies, and I learn that there are customers that are really innovating and that they have the resources to be impactful at the moment. And you see, on the basis of these, right? From our side, we really want to understand how to envision ways to use quantum computers in the future. And we want to help people that are building quantum computers. And you see, we want to learn how to make quantum computers part of a complex IT infrastructure as the AWS cloud. And sorry, there was a slide that appeared as some kind of subliminal message. I go back to that. So that's the elephant in the room, right? The elephant in the room is that nobody really knows the timeline for quantum advantage in business. And we all know that, right? Either consciously or unconsciously. And of course, quantum computers are important scientific tools. They're impactful in many ways. But you see, this elephant in the room is what really drives our stance in the industry. So right now, it's still the moment of discovery, right? It's still the moment of science, the moment of transparency, right? And we should push as much as possible so that that elephant can get out of the room. And you see, maybe it's very hard to predict where quantum computing is going to impact the industry. But there is also a risk in being caught off guard, and definitely great opportunity in managing the uncertainties wisely. This is a sentence by Michele Mosca, which I quite like. And so customers want indeed to get the elephant out of the room, right? And want to make things happen faster. So customers want to build business applications or scientific knowledge, of course, which is impactful, but they want to have confidence in investing. They ask if and when, why they should get ready for quantum computers. They want to have access to hardware, but are not sure what hardware because technology clearly is evolving very fast in many parallel directions, right? And they do not want to commit upfront capital, is possible. So customers have already complex pipelines on AWS and want quantum computers to be fully integrated. So what is called a fully managed experience. And all of this expressed, obviously, the ultimate desire of accelerating innovation. And you see, on the basis of these considerations, right, what can AWS contribute? How can AWS work to become quantum ready together with our customers? And this is my second point. number 2. What can AWS contribute? So we think that the clouds, right, the cloud and the attributes of the cloud can bring some value to the industry. And we believe we can contribute. Also because, you see, we have learned a lot about bringing new technologies to market. So think about insight that we learn from technologies like machine learning, for example, or from Internet of Things, or from robotics. These are technologies that evolved over the last decade at least, and we learned a lot about these technologies by talking to customers. And now we have a lot of customers that are bringing these new technologies to market. And this is what we are building, I guess, right now to get quantum ready together with our customers. So the very first thing is something called Amazon Braket, which is a tool that everyone can use. You can access it today from the AWS console. And Amazon Braket is an AWS fully managed quantum computing service. It's designed to help, on one side, scientific research, on the other side, software development for quantum computing, so meaning people that are figuring out software and quantum algorithms. And it provides a set of hardware-agnostic developer tools, classical quantum circuit simulators, and access to a variety of quantum computers today to enable users to build, test, run their quantum algorithms. And this is on demand, right? Pay-as-you-go is available now. It's been in general availability since August 2020. And, but also, we understood that it's important to help some customers engaging with the technology. So we have an organization which is called Amazon Quantum Solutions Lab, which is a team of subject matter experts in quantum computing whose mission is to help AWS customers accelerate their understanding of quantum technologies, understanding if and when a quantum computer could be impactful in their business. And what do? They run collaborative research programs using expertise in quantum computing, but they also work in machine learning at HPC. And you see, we also launched an organization which is called AWS Center for Quantum Computing, and we want to learn as much as possible about quantum hardware. And we want to help contributing accelerating innovation on the hardware level. And so we launched this organization in 2019 with the goal, indeed, of accelerating the development of quantum computing technologies at the hardware level. So this center is really a key part of our long-term vision for quantum. And the center is led by two scientists, Oscar Painter, that takes care of hardware, and Fernando Brandao, that works more on the error correction and the theory side. This slide here aims to show how we fit in this community. From the perspective of researchers and users and developers, we are trying to solve 3 problems here, right? So first, access to different type of hardware. Second, integration with non-quantum resources and services, and an interplay between quantum and classical resources. And third, we would like to offer a consistent experience. So an operational performance, which is not easy actually to achieve, and something which in which we have a lot of experience, right? And we believe that by building something like Amazon Braket, there is also benefit for people out there building quantum hardware, because this offers a route to customers and also enables hardware builders to focus on what they're trying to achieve, which is building quantum computers rather than building infrastructure, which I think is valuable, because the ultimate goal in the end is building quantum computers, not infrastructure. So now this is a pretty busy slide. It's an architecture diagram of Amazon Braket. So don't spend too much time looking at this slide. The message here is that, you see, Amazon Braket is part of a complex IT machinery, right? And it uses multiple services inside AWS because it's truly integrated in the cloud. There are just some I don't need to spend time here describing the services that Amazon Braket uses, but CloudWatch for monitoring what is happening, Event Bridge for notifications, Amazon S3, which is storage, and you can manage the access via AWS Identity and Access Management. And right now, I guess that in looking at this slide, the message really is Amazon Braket is truly integrated. It truly integrates quantum computers in the cloud. And so we have choices for different quantum computers. So right now, you can access 3 different types of quantum computers. We want to give choices to customers, as we do with classical hardware. And we have 3 different types of hardware in general availability. We have D-Wave, quantum annealers built by D-Wave. We have some ion trap machines, quantum computers, so gate-based quantum computers built by IonQ, and some superconducting devices built by Rigetti. And this hardware, you see, is on demand, pay-as-you-go, in general availability since August 2020. And a week ago, last week at re:Invent, our annual conference, we also announced that we are working on the integration of processors built by 2 other startups, which are Oxford Quantum Circuits and QEra. Oxford Quantum Circuit is a UK-based startup. They have their own twist on gate-based superconducting processor, the so-called coaxmon, and this is in Europe. And I hope that by integrating Oxford Quantum Circuit device, we'll support positively the UK quantum technologies community. And the other machine is built by QEra, which is a startup in the Boston area. It's close to Harvard, MIT. And they're building a different type of processor, which is based on Rydberg atoms. And this is well suited to simulating a variety of natural systems and for working with specifically analog Hamiltonian simulation. And there is already exciting research that is happening in relation to this topic. So I'm very much excited to welcome these pieces of hardware both on Amazon Braket, and I'm looking very much forward to have them available on the service soon. Now, let me move to an area which moves a little bit away from hardware, and it relates to software. So last week, again at re:Invent, we announced something called Amazon Braket Hybrid Jobs in general availability. So Amazon Braket Hybrid Jobs is available now, generally available in all regions where Amazon Braket is available, and can be used in all devices on Amazon Brakets, and including quantum hardware and classical simulators. Okay, what is this? So before hybrid jobs, through Amazon Braket, you could submit tasks to simulators or let me call them quantum processing units like quantum hardware, and you needed to manage this interaction. What we have introduced here is some new instance, which is an hybrid job instance, which is a classical machine on the cloud, which is responsible for orchestrating the interaction between classical and quantum compute. And this is very customizable, meaning that you can create custom containers for the ones among you that are familiar with this term from software engineering. And then you can monitor your progress. And people that are familiar with hybrid quantum classical algorithms know that it's important to monitor what is happening while your algorithm is converging towards what you want at the end. And so we have ways to monitor what is happening and potentially adjusting the computation while the computation is occurring. And finally, for the duration of the algorithm, hybrid jobs has priority access to the selected quantum processing unit, which ensures faster and more predictable performance for customers. Now, we are in this NISQ phase. I'm not sure if hybrid jobs, if hybrid algorithms, quantum classical algorithms, are really going to deliver something which is impactful in business. But here we lift the heavy weight of orchestrating quantum classical resources. And what I like here is that one reason why this makes sense, why it makes really sense to be on the cloud, when working with quantum computers, is that in the long run, right? And I'm not sure when, we will have QPUs, GPUs, CPUs, and we have these microcomputer resources beyond quantum classical algorithms. And for example, right, you want to run a quantum algorithm, often you need classical post-processing, right? So the quantum part is not the whole story. You need classical post-processing. And so building something like hybrid jobs on Amazon Braket is not just about variational quantum eigensolver. It's not just about variational algorithms, but it's about anything that includes quantum classical stuff. And we need to learn as much as possible how to build that. And suppose in a future, in a future which maybe is science fiction, maybe it's not, at some point people will want to create a digital twin of a molecule, right? And so how do you do that? Of course, you will need a quantum computer, but you need all sorts of other resources. And this is when hybrid is really taking over, and this is when one needs to figure out infrastructure and ways to have quantum classical resources talking to each other. And Amazon Braket hybrid jobs is a tiny step in this direction, right? And here on the screen is an example where you can create secure and custom API for your users by using some AWS services like Amazon Cognito or Amazon API Gateway. And in this way, via these APIs, you could access Amazon Braket, but via the same API, you could build access to HPC resources. And this is a tiny step in the direction of people indeed moving from this idea of monolith to microservices, and that tiny step towards thinking about quantum computers truly integrated in a complex IT infrastructure in the cloud. And this is something which I like. So now let me go to point 3 here, which is innovators are building on Amazon Braket. And so AWS Partner Network, right, is a global program focused on helping partners building a successful AWS-based business. And this is a network with over 100,000 partners from more than 150 countries. And you see on this slide is a sample of companies that are building on Braket, or they're working together with our professional services team. And this is about building solutions, of course, but it's also about building consulting services, since customers often want expertise to be guided in their journey, to learn, to experiment with quantum computers, and also to get started with AWS, right? And here there are startups, and there is like Infosys is a large organization, in fact, a premier consulting partner for the AWS, and it's building now Infosys a center of excellence on quantum computing in collaboration with AWS. So startups and also large organizations, and actually there is a chance that this list is far from being exhaustive, and my apologies if anyone is in this room is not represented in this slide. Please accept my apologies, and please come to meet me or come to meet us at the booth, and I'll fix it. So let me give you a couple of examples, which I think that they are meaningful. I want to give you a couple of examples of what people are doing by using Braket as part of AWS. So here is Q&Co. So Q&Co is a startup in the Netherlands, and thanks for partnering with us. And they built QBEC. So QBEC is a quantum computing platform specifically designed for chemistry and material science simulations. And they have some proprietary quantum algorithms that do hybrid quantum classical stuff with an optimization loop, and it's built on AWS and uses Amazon Braket. So customer can access these from a fully managed AWS account that is built by Q&Co, but they can also integrate QBEC into their AWS environment. And what I like on this figure right here, which probably is complex, but it doesn't matter the complexity. I think that it's just important to see that this is an architecture diagram with Amazon Braket is a detail, right? And there are other services that are needed to build QBEC. And I'm quite excited about the fact that there are people like Q&Co that are, yes, using Amazon Braket as a tool, but they're using also other stuff that allow them to build something where quantum computers are fundamental but are just a part of a larger story, and which is interesting. So for more details on this, please refer to the AWS quantum computing blog at the bottom. I will have a slide later with some links for websites and including the blog. So second example is QCware. So QCware, the company that organized this conference. So and thanks QCware for partnering with us. So they are building Forge, and you see QBEC in the previous slide is something that can be deployed by customers in a customer AWS account. But Forge is built by QCware, is pure software as a service, and this allows researchers and commercial customers to easily access quantum computers and it's focused on data science. And it runs models on Kubernetes clusters using CPUs, but also GPUs nodes before pushing compute to QPUs through Amazon Braket. And there is a variety of software that QCware Forge is using on AWS, including Prometheus, Grafana, for the ones among you that are familiar with these tools, but also databases like Aurora DB and S3 and so on. And you see, with a click of a button here, you can access a variety of algorithms for data scientists, like binary optimization, linear algebra, machine learning, and it leaves the complexity for people that want to explore quantum computing via this environment, and it makes it simple, which I think is valuable. And again, for more details, please refer to the AWS Quantum Computing blog, or of course, to the website of QCware. Now, let me move to my fourth point, which is we are investing in the long-term potential of quantum computing. Let me tell you what we do with hardware today. So in 2019, we started an organization called AWS Center for Quantum Computing, and the main facilities are in Pasadena. And so in fact, we have a dedicated building that we built very recently in the campus of Caltech. And I think that this is important to have such facility, specifically in the campus of Caltech, because Caltech is an institution with a strong history in physics and in quantum science. And I actually hope that even our presence there can contribute positively to the Caltech's context also for students and researchers. And so what are we doing there? So let me tell you a little bit about our perspective on error correction. Right? We are interested in error correction. Well, why? We believe error correction is fundamental. Error correction is important, but there is a price to pay, right? And we all know that there is overhead. So overhead means that as soon as you have a little bit of physical error rate for each gate, if you want to build a quantum error correction, you need to add many physical qubits for each logical qubit. We have seen in the slide by John Preskill just this morning how costly it is in terms of physical qubit to build logical qubit specifically for the for surface codes, right? I guess that the price to pay is about 2 times d square, where d is the distance, right? And so error correction in quantum computing is important. We should not underestimate this important, but there is a price to pay. And so now the idea is let's try to build some hardware that gives more efficient error correction, right? That's something that requires a lot of effort, and many people are considering out there now called cat qubits in harmonic oscillators. And you have some microwave on a cavity and an harmonic oscillator, and with equally spaced energy levels. And instead of a qubit at these 2 levels, let's look at these multiple levels, and let's try to figure out a way to encode information so that you can have some built-in protection against errors. So anyhow, you do some coherent states, opposite phases. Forget about what I'm saying here. Just something called cut state, which uses harmonic oscillators, right? So you can engineer your system to protect cut states against bit flip, which is one of the 2 errors that happen in quantum hardware. One is bit flip, so you flip bits from 1 to 0, and the other one is phase flip, right? So you flip the sign of your superposition. And so by following this approach in our center, so this is the chip that we built there recently, and the dash cycle is the microwave oscillator where we implemented the cut qubit. And so we have built this, and this device has shown an experimental improvement, or 3,500x in coherence time with respect to the case that does not use cats. And so it means that the bit flip lifetime of the cat that we built in the lab there is about 10 milliseconds, which is interesting. And of course, if you want to get a logical qubit, you need also to correct phase flip errors, and this is something that we are working on at the moment. And definitely is still a steep mountain to climb. But I'm excited about this result, and this improvement is promising, and it shows that possibly building cats in the lab is an exciting thing to do. It's something that hopefully will reserve us some interesting surprises. Now, I have just a technical slide here. No point that I will spend time on it. For the more technically minded people that want to see some numbers, this is a plot of the experiment. Actually, you will notice that the peak here is alpha square, which is about 6.5-ish. So it's an earlier experiment, but we actually measure something above 10 milliseconds in more recent experiments. But if you want more details, I'd be happy to put you in touch specifically with the scientists in our team, and please come stop to our booth or just get me after my talk, and I'm happy to give you some details about this experiment, which I find exciting. Right, so fifth and last point, and this is probably the most important slide of the presentation: how do we work together? You see, solution providers that are building products and services, please get in touch. We can start a conversation together with our APN, partner network managers, and this is a way to work together for sure. As I show you already, there's a number of companies out there that are doing this with us. If you're conducting research, please do get in touch. We have an extensive program to give credits to researchers to access the quantum hardware available on Bracket today. And you see, enterprises that are problem-centric, that are focused on well-known pain points, but tech-agnostic, would find it interesting to talk with our Amazon Quantum Solutions Lab. And of course, everyone can use Amazon Bracket. You don't need to talk to the Amazon Quantum Solution Lab. But if you want to go deep, to dive deep, and accelerate your learning or your research journey, Amazon Quantum Solution Lab is a good team to have a conversation with, and even explore things that have to do with HPC and machine learning with an interface with quantum computing. And finally, of course, if you're building a quantum computer, please reach out, and we can help you reaching your customers. And these are just, so if you want to take a picture for some resources that are available on the internet for learning more about the stories that I've been telling you now during my presentation, that's a good slide. Take a picture. So I still have a couple of minutes here, and I want to conclude with a slide that doesn't fit really the presentation, but I think it's meaningful, and I feel happy if I conclude with this slide. And so this is a picture of Charlie Bennett, which I took in 2017. In fact, in December 2017 in Beijing, there was a conference in Beijing. I was there. So after Charlie Bennett was telling me a story about cellular automata, and you see, this is an interesting sentence, right? So the greatest achievement of our field won't be to speed up computation or to communicate secretly, but to help people understanding that this world is quantum mechanical. During his talk, he said this phrase, and I like it because he gives the feeling that the deepest, most impactful innovation that comes really comes from a deeper understanding of nature, right? And there may be hype, there may be over-optimistic expectations out there. However, I believe that in the end, the fact that there are so many people in this conference, and a conference between industry and academia, and an open conversation between industry and academia, I think is remarkable. And it's really a step forward, the kind of success that Charlie Bennett is described here, right? And possibly innovation that will be potentially enabled by quantum computers in the future is beyond what we can really imagine now. And the fact that we are here in this room is exciting and possibly a step towards that. So thank you all for your attention.